Okay, so today we're going to be going over absolute maximums and absolute minimums of a various function. And so there's a really good rule for looking at these. And so an exponential function that goes on for infinity. We're doing functions that go on for infinity. If the function goes on for infinity, it can either have a minimum or a maximum. It cannot have both, because it'll either go off into positive infinity forever or negative infinity forever. So you can only have one maximum in. And so there's a way to figure this out by only looking at the lead coefficient of your most powerful polynomial. So in this case, it's x squared. And so there's a rule over here. Now, if you don't remember anything from this, the most important thing to keep in mind is this here, this highlighted area. So if you notice, we have an even power and a positive coefficient. So even power and a positive coefficient means absolute minimum. So we know this function has an absolute minimum, and it goes on to infinity in the positive direction. So it cannot have an absolute maximum, but it does have an absolute minimum. And so once you figure this out, it's actually the same technique as finding relative minimums and relative maximums. When you take the derivative, you set that to 0, find the critical points, and then the absolute min will take place at one of the critical points. But they can't all be absolute mins, only one of them. So the smallest value out of those problems will be your absolute minimum. Let's go ahead and take the derivative of our function. We're going to get 2x minus 1. Set it to 0. We're going to get x equals 1/2. So that means there's an absolute minimum at x equals 1/2. So you see, it's actually a very simple process. The tricky part is figuring out whether you have a minimum or a maximum. So f has an absolute minimum at x equals 1/2. Okay. And sometimes it'll ask you for what that minimum value actually is, and all you do is plug in the 1/2. So we can just do that really quickly. F of 1/2 is equal to 2 times 1/2 minus 1. 2's cancel. F of 1/2 is equal to -1. Okay, so that's the absolute minimum of the function, -1. And it takes place at f equals 1/2. And so next, find the min or max, the absolute min or max of the function, -3x squared minus 9x plus 4. So we have an even power and we have a negative coefficient. So let's go over here, even power, negative coefficient. That's going to mean we have an absolute maximum. So just so we don't forget, we know we have a max. So now we're going to take the derivative. It's going to be -6x minus 9. Set it to 0. We can pull out a -3. And we're going to have, we're going to have 2x minus 3. And then we solve for x here. X equals 3/2. Yeah, x equals 3/2. Okay, oh, wait. You would, this would be positive. And so you'd subtract it, so then you get -3/2. So x equals -3/2. So this is our absolute minimum here, or absolute maximum, sorry. So f has an absolute max at x equals -3/2. And so we only had one critical point, but if we had two critical points, we would need to substitute in the x values to get y values, and whichever has a higher y value is the absolute max. But we'll find the max just for the heck of it. So f of -3/2, plug it into the main function, -3 squared minus 9 -3/2 plus 4. So here we have -3/2 squared. This is going to be 9 over 4, 27, -27 fourths plus 27 halves plus 4. So we could make this all into fourths. We'd have, well, first of all, this cancels into just a positive 27 halves. 27 fourths, sorry. This cancels 27 fourths, plus 4 is plus 16. So our f, -3/2, is going to be equal to 43 fourths. Okay. So we've had an example with both of our examples have had even powers, but one was a negative coefficient, one was positive. Now we're going to go to an odd function. So we have an odd function and a positive coefficient. So odd power, positive coefficient, that means we're going to have another absolute max. So let's just go ahead and write down max so we don't forget. Okay. Take our derivative. We're going to have 3x squared minus 6. We can pull out a 3 here. After we set it to 0, of course. We can pull out a 3. X squared minus 2. And then plus or minus the square root of 2. So in this case, we actually have two relative max or absolute maximums. So of course, only one of them can actually. We have two critical points, and only one can be the actual absolute max, or they both can be, but it has to be the same y value. So we're gonna plug it in here. So we'll do positive first. So f of square root 2 cubed minus 6 times root 2 plus 16. I'm actually going to punch this in on the calculator because the math is so messy. It's not worth keeping in square root form. So 2 to the 3/2 minus 6 root 2 plus 16. So this comes out to be about 10.34. Now let's go to f of negative square root 2. And our answer should be different because we're cubing a negative. negative squared cubed minus 6 plus 16. So this will cancel out, become a positive. So let's go ahead and do this math here. Negative square root 2 cubed plus 6 root 2 plus 16. So this one ends up being 21.65. And so now we know that, oh, this is actually our absolute maximum here. The other one is just a critical point. And so we know F has abs max at x equals negative square root 2. And the value is about 21.65.